Hello, and welcome to the session about bootstrapping VMware, the infrastructure as code way. What we're talking about in this session is BYO infrastructure. It's an approach to automating VMware at the bare metal level and then upwards. I'm Rob Hirschfeld, your guide for this session. I'm co-founder and CEO of RackN, and I've been doing data center automation and VMware data center automation for over 20 years, believe it or not. You can find me online. I'm at Zehicle, and I've been very active with something called the 2030.cloud, where we talk about a lot of advanced futuristic concepts in DevOps. And so what we really want to talk about here in an infrastructure as code sense is to look at this traditional infrastructure stack that we've built. Because we know that if we fix things at the bottom, that physical layer, then everything we build on top of it, and this is a totally standard VMware infrastructure stack. It's something you would see in other vBrownBag presentations. As a matter of fact, it's modeled on them. So what we've seen is that while people like to squeeze the physical layer at the bottom of this down into this tiny part of the stack, it's actually a complete stack in itself. It's not just a small box. It's actually compute, storage, and networking components that you have to get right, and actually very carefully right, in order to make everything we build on top of it work. And so at RackN, we spend a lot of time thinking about exactly this problem and how do we treat these components like a cloud. And a lot of what that means is, how do we take DevOps automation pieces, infrastructure as code concepts, and automate that physical layer also? Because if we can do that and use the tools and techniques and all the great cloud-like style, we can really make a huge difference in what it's like to actually run a data center, really transform it in very positive ways. And that's what we want to talk about. It's worth mentioning RackN Digital Rebar is this product that we have that's designed to help companies self-manage VMware. So we're not a consultancy, we're not a service provider. We're literally helping companies manage their own VMware infrastructure, whether it's legacy, new, or edge infrastructure. And so that's really about automating infrastructure, securing it, and making it portable so that you get reuse out of the problem. So we see this quite a bit. We're helping multinational customers and service providers automate VMware and do it themselves. So we have a lot of experience with this. And what we've learned in this is that there are really 6 key factors in design that you need to understand before you even write a line of code or a line of infrastructure as code in this case. And so in those factors, we have an organizational component where you really have to be able to say self-management is possible. I can do this myself. I don't have to turn it over to a VxRail or an HCI vendor or a cloud, that you can actually do it, right? And believe that you can do it. To do that well, you have to have human understandable operations. So people have to be able to see what's going on as we automate it. And then once you've done that, it has to be continuously repeatable. We don't look at infrastructure as code and think that it's a one and done thing. You have to be able to keep redoing this. One of our customers calls this repaving their data center. And they literally roll through upgrades and patches in a 30-minute window, and they repave entire 100 system VMware clusters in that time window. And that is how they create these repeatable, robust data center infrastructures, by being able to just click a button and rebuild everything in their data center. And then on the technology side, we also have to approach infrastructure as code in a systems way. So when we look at this, we're not just trying to solve one problem. Can I provision a machine or can I configure it? We're actually connecting a whole bunch of pieces together, from certificate management and inventories and manifests and DNS. All has to be done together. Otherwise, we're really just creating little islands of automation. To make all this stuff work, it has to be observable. So black box things where something happens by magic do not create reliable infrastructure as code things. Any place where you're pointing to a black box and saying Darby Dragons, you're going to have a problem with your automation and in your code. And that's a lot of what we're trying to do, is take everything that we do from an automation perspective and put it in a code repo so that it's available and you can see it and inspect it and make sure it changes and that you know it changed. There's no people running around behind the scenes and flipping bits to make sure everything works. And then we're creating connected automation. So chains of automation that all work together as a system. So a complete integrated workflow. So I want to take you through how these 6 principles really fit together into deploying VMware from the ground up. This is what we do on a normal basis. The first couple slides of this builder are just our normal discovery process. We take every piece of hardware, ARM, Intel, whatever vendor you have, cloud or physical, through this standard process. And then we'll actually be able to inventory, verify its hardware, set RAID and BIOS configuration, do out-of-band management, all these processes just to get the machine up and understand what the machine is. Perfectly normal, we do that in every case. And then for VMware, we extend that where we actually use the net boot that VMware has available. We'll pixie boot into ESXi, and then we'll install VIBs that can take additional actions in ESXi. And this is a really important point in automating this infrastructure. In order to do this effectively in an automated way, you can't create an island where ESX requires its own automation or its own manual steps. What you really need to do is come back and have a way to complete the ESXi infrastructure inside. And that's security, setting patches, installing certificates, making sure that your networking configuration, getting off VLAN 0, all those bits and pieces have to be done correctly to do it. And our VIBs are actually signed, so we can do this all with a secure boot infrastructure, which is also absolutely critical to building really robust, reliable infrastructure. And then we can hand off to downstream infrastructure. So if it's Cloud Builder or something else, that's where we now have enough information that however you want to automate on top of that, you have the information that you need, whether it's Ansible or Terraform or whatever mechanisms, or if you're back into CSV spreadsheet land, you have the data that you need to make that all work together. And that's really where we start pulling together these infrastructure as code concepts, because everything I'm showing you in this list are all components and modules that fit together. It's not a big bash script or an Ansible playbook that works, if you put in a whole bunch of value. It's actually things that you plug servers in and just the right things have to happen. And that's what makes infrastructure as code really interesting. And it's not just another HCI story where buy this exact hardware, put things together in exactly the right way. People's data centers are different. And for good reasons, they're different. And so we have to be able to accommodate those differences and let people bring in their own infrastructure and their own legacy infrastructure. And as we go migrations from 6 to 7, you have to be able to take what you have. You shouldn't have to buy completely new infrastructure. And so here's what we hear for customers talking about their needs from infrastructure as code. They need to have useful abstractions. And we're going to go through each one of these, and I'll show you an example of how that looks, and orchestration. But at the end of the day, what we're really doing is working to eliminate manual steps and silos. It really is that simple. That's the goal for infrastructure as code. So when we look at modularity, the idea here is that we're not just looking at a single script. What we're looking at doing is taking big problems, how do we automate a system start to finish, breaking it down into small pieces and making sure that each one is modular and then ultimately understandable. And that lets us build a catalog where things that aren't VMware specific or Linux specific or Windows specific can actually be downloaded and reused, right? RAID and BIOS configuration, while tricky and finicky, is not unique. No customer has unique BIOS configuration. They might have different settings, but the process and the way you do that is something that we can standardize and we can pull in and get code reuse from. And that's really important. And then really importantly to us is if you change it and you extend it or you add to it or you add your own magic sauce, which everybody has, then you have a way to code that, manage it, create your own catalog. Because infrastructure is code, the as code part, a lot of that comes from how you store it and manage it and version control it. All super important. And then from there, you have to be able to understand how these pieces work. And that means that these big modules don't just break down into big modules. They actually have to have clean and understandable inputs and outputs with good documentation and types and clear delineations. And then the big steps have to break down into smaller steps that you can understand. And that can go for us, it goes from workflows into stages into tasks. Tasks actually can decompose into templates because we want to get reuse. And that means that if we solve a problem once, we want to be able to rebuild new modules, click things together in ways that actually create reusable pieces. And that is really helpful because when you're building an infrastructure start to finish like this, we're crossing teams. There's a human element component to how all this stuff works. And so that means that we have to be able to show another team what we've done in a clear, concise way. And then we have to have a handoff so another team can do that work. And that's okay. They have clear inputs and outputs. They put their pieces together, and then we fit everything together into a simple workflow. And that's really a key component for this, because it's not just about, can I provision a machine? It's, can I build a cluster? Can I build clusters and more clusters? Can I go to remote sites? And so there's a concept of building workflows that actually go through and pull all these pieces, these infrastructure of code pieces together. So if you have a Terraform template and an Ansible playbook and a bash script and a pull this ticket and this person has to go turn on a network port, that's not really an infrastructure as code workflow. It's a collection of tools, but they're not built together to deliver a consistent long-term deliverable. That's really what we're talking about, what we would call intent-driven infrastructure. I need you to build a cluster, start this process, everything else should be able to flow out of that. And then from that perspective, that sounds very cloud native, it is. And it's this way of thinking about API-driven infrastructure where you're asking for a request and things are getting done for you. In a lot of cases, we don't expect people to use our system directly or sit in the UX, right? This should be, I need to build a cluster. That should be triggered by external events or other systems or things up stack from where we are. That API-driven mentality is essential to building good infrastructure as code. Once again, it's all codified infrastructure. Those APIs become the gateway between different systems and help you connect all these pieces together. And then finally, one of the most head-shaping things that we've had to learn in this is that building infrastructure of code means that you have to cross context boundaries. So in the work that we're doing and the thing that we found to be really powerful in making it all come together is this idea that I can bounce my context back and forth. I can do work in a machine. I can pull up to a cluster level, verify that things are right, return back to the machine. And this ability to move back and forth from a context perspective really changes the game and how you can automate something, because you can build a single workflow that has different security contexts, collects information, can work across the cluster, and coordinate activities in a way that is absolutely essential to accomplish this end-to-end system driving perspective. So I hope this helps you understand how we see infrastructure as code and really where the industry is going, because this isn't pie in the sky things. This is actual work that's being done by customers in the field. They're using these techniques. They're actually building data centers and clusters based on infrastructure as code practices that are repeatable, safe, and secure. Whether it's a brownfield system, it's a greenfield system where they're bringing in new ideas and new capabilities, and then being confident that the things they've done aren't going to be locked in for the next 10 years, and they'll be able to change and keep revisiting how things go. If this is exciting and interesting, please, we'd love to have an extended conversation with you at RackN.com. And everything I'm talking about, we have people doing. You can try yourself. You can just download Digital Rebar, try the VMware pieces, build your own clusters. The stuff we're doing is really designed to be that simple, because we're helping people self-manage their infrastructure, not take over control from them. So, thank you for spending a couple minutes with me learning about infrastructure as code. This is Rob Hirschfeld from RackN.